Hello everyone, so welcome to another LeetCode question, and today we will be solving maximum subarray. Okay, so let's see what the question is asking. So we have been given an integer array called as nums, and we have to find a contiguous subarray, and it should have at least one number should be there, at least one, and which has the largest sum, and then we have to return its sum. So this is what the question is. Let's see, go through a few examples to understand what the question needs as output. So for example, if we have given this nums array, okay, if we are given this nums array, we have -2, 1, -3, 4, -1, 2, 1, -5 and 4. Now the maximum contiguous array sum here would be this contiguous array, and the sum of this will be 4, -1, 3, 3 plus 2, 5, 5 plus 1, 6. So in this case, the maximum contiguous subarray sum is 6. Now in this array, we have array nums, and there is only one element, which is positive 1. So what we can do, we will return 1 as the answer. In this case, nums, we have 5, 4, -1, 7 and 8, right? So even if there is a negative number, but we know that just after -1 we have some positive sum. So we can quickly see here that 5, 4, 9, 9 minus 1, 8, 8 plus 1, 15 and 8, 23. So 23 will be the answer here. Let's go through the intuition. So what we can think here is that we can take a subarray at a time and calculate its sum, and then we will try to keep track of that sum and the maximum sum that we have encountered so far. So we'll take all the subarrays, calculate sum individually for each subarray, and then we'll compare it with the maximum value so far that we have encountered for each subarray, and then we can return that max sum. So this looks like a very straightforward solution. Let's go through the brute force solution for this. So for example, if we have an array like this, we'll keep an integer variable I, an index tracker, and a j index tracker, right? So what can happen is my j will go from, so I can go from here to here, and j will start from I and then go from here to here. So at any point of time, let's say my j is here. So what we can do, from here to here, we can calculate this sum. We can calculate the sum between I and j, and then we'll keep a maximum variable and update it with this sum. But if it is greater than the maximum sum that we have previously encountered. So this is a very straightforward thing. We can just have a brute force 2 loops, and for each 2 combination of indexes I and j, so for example 0 and 4 we have, or we can have 1 and 5. Between these 2 indexes, we'll calculate the sum and then try to update this maximum variable. But if we look at this thing and try to estimate a time complexity for this, what will happen is that for I and j, for 2 loops, we know that it will take n squared time complexity, right? But to calculate the sum between 0 and 4, this will again take n. So what will the time complexity for this case? It will be n cube. But can we do it better? Can we reduce this time complexity to big of n square? Can we do this? There is one optimization that we can think of here, is that, let's say if this is my array, let me just quickly copy this. I've copied it, I'll paste it here. Now let's go through this. So what we can do is, let's say my I is here, and what we have is j, right? So at I, what we'll do, I'll keep a sort of current sum variable, let's call it cs. This will be 0, and then my j will run from I till the end, right? So what we can do, we will have a maximum variable, okay? So we have a current sum variable. This is what we initialized when for the first index I, and then we have a j that is running from I to end. Then we have a maximum variable, let's call it ms, and this is the minimum value, right? So this is the minimum value, and cs is equal to 0. So while going from I till the end, what we can do, we can, in cs, we will add this value, the value in nums at index j, and then we will, in maxsum, will store the max of maxsum and this value, right? So what will happen is, let's say we were here, so initially it was -m, then we have -2, so -2 and -1, which one is greater? So we have -2 is greater, so we'll have -2 right now. Then my j is here, and I'll add -2 plus 1, so we have -1. Which one is greater? -2 and -1? -1 is greater, so ms will become -1. And this way we'll keep on going with the j till the end, and we'll update this maximum variable. right? So if you look at this very carefully, if my I, when I is here, we are covering these arrays, right? -2 to 1, then -2 to this one, and then forward like this. So this will encapsulate all the sub arrays, and we are able to do this by only running 2 loops, that is big O of n square time. So this one optimization I want to discuss in the brute force solution. Now let's go through the optimized solution. This is actually a very popular algorithm, also called as Cadence Algorithm, right? So if you think about it very carefully, which sub array is worth keeping, right? So Cadence Algorithm makes us force to think about this question, that which sub array is worth keeping. If you try to look at this, let's say we have 1, 2 and -4. 1, 2 and -4, or let's say, yeah, so this is this sub array. The sum at this point is 1, the sum at this point is 3, but the sum at this point is -1, right? So 1 and 2, 3, and 1 and 2 and -4 is -1. So if we have at any point of time sum is -1 or negative, do we need to keep this value for the rest of the values that are there in this array? No, right? Because anyways this sum would try to decrease the next sum that we have. So that's why whenever we encounter a sum as negative, we can ditch it and make it 0, right? And then we can go forward and think about it. But if we have like 1, 2 and -1, and we have some elements forward as well. So if we have 1, 2, 3 and -1, at this point what we'll have? We will have 2 as our sum. And does it make sense to keep this negative number or this positive value and keep on thinking about the rest of the array? Yes, it does, right? Because if we had more positive values here, let's say the sum of this remaining numbers is 98, right? So we can think of it like that, ki these two values actually make sense because these two along with this number is giving us a positive response, and adding this to the remaining sum will definitely give us a larger value. So it makes sense in this case where including a negative number, if it gives us a positive response, we can take it up and try to figure out the rest of the sub array and calculate the maximum sum. Okay, so let's go through this example. So if we have -2, and in the question we saw one thing, that the sub arrays should contain at least one number. So if we have let's say all the negative numbers, right? So -2, -3 and -1. So in this case, what will be the maximum sub array? It will be -1. So let's go to this. So we'll keep two variables. One is global sum and the maximum sub array sum. This is the value that will return after we complete the algorithm. So we have -2. We'll add it to our global sum. So this will become -2, and maximum sub array sum, let's say initially it was -infinity, right? So now we compare this maximum sub array sum with the global sum. Global sum is greater, so we'll update it to -2. But since this is negative, as we told earlier, that if the current sub array sum is negative, we can ditch it and reset it to 0. So this will become 0, right? After this one, what we'll have? We will have 1. And is this sum greater than the current maximum sub array sum? Yes, it is. So we'll update it to 1. Now this is -3. So we'll have here -2, right? 1 plus -3. 1 plus -3. This will become -2. And between -2 and 1, which one is greater? 1. And we'll reset this to 0. Okay. Then we have 4. So our global sum is 4. And is it greater than the maximum sub array sum? Yes, it is. So we'll update this to 4. Now we have -1. This will become 3, right? This is the second case that we discussed here. So we'll still keep it. We'll have 3. Is it greater than the maximum sub array sum? No. So we'll keep it to 4. Now we have 2, 3 and 2, 5, right? So 5 will keep in the global sum, and maximum sub array sum between 4 and 5, which one is greater? 5. So we'll update it to 5. Now we have 1. The sum will be, global sum will be 6. Between these two, which one is greater? 6. So we'll update it to 6. Now we have -5. We'll add it to 6. We'll have 1. Between these, which one is greater? Obviously 6. So we'll keep it 6. Now we add 4 to this sum. Which one is greater? We have 5. And between 5 and 6, which one is greater? This one. So this is 6. So at the end of the algorithm, we'll return 6, right? So the important thing that we need to understand in Cadence algorithm is which subarray is worth keeping. So this question we have to keep in mind, and most of the time you will be able to figure out the algorithm of this solution. Let's discuss time complexity and space complexity problem. So we went through linearly. In one iteration, we are able to figure out the maximum continuous subarray sum, and we didn't create any auxiliary space, so the space complexity of this problem will be constant, which is big of 1. Let's go to the code walkthrough. So what we discussed is we are given an array and we will return the maximum subarray sum, and this is what the interface of the function looks like. Okay, so what we have is we have a global sum that we initialize it to 0, and we have maximum subarray sum that is initialized to -infinity at this point of time. We start from 0 to the end of the array, and then we add the current number to the global sum. In the maximum subarray sum, we check whether the maximum subarray sum between the global sum, which one is greater, and we assign it back to the maximum subarray sum. And we said that we'll reset the global sum. If the global sum is less than 0, we'll reset it to 0. And then finally, we can return this maximum subarray sum. So this concludes our problem, maximum subarray sum. Okay, thank you.